Complex numbers.
I don't know.
You
-1.
you hard math.
I hard.
The square root of -1
Equals math.
is I. The square root of -1. Remember, when you take the square root of a number, you're looking for two numbers that are exactly the same that you multiply together to get you that value. Now, when you take the square root of, let's say 4, two numbers that are exactly the same that you multiply together to get 4 would be 2 times 2 or -2 times -2. Do you agree? Now, what happens when you have a square root of a negative value is that you get this, it doesn't work. You can't do that because one number would have to be positive and one number would have to be negative. Do you agree?
Yeah.
Those would be different numbers. It's crazy, but it can happen. The square root of -1 equals I. I heart math.
Wait, why? Oh, I did it.
They write the I values lowercase with a tail. It's just kind of a common courtesy way of writing it. It's the math etiquette way of doing it. It's not that they use this. They don't normally use that. They use a cursive style for the imaginary number letter. You can see it like that. So, what's that? I'll show you how you can actually use these things. So basically, what this now allows us to be able to do is, yesterday you guys were solving all those types of equations that had plus or minus square roots. Well, now you've just doubled the amount of questions we can do. Now we can have negative answers.
Oh, yes.
Yes, it's exciting. So here's what happens. The two things I want you guys to take from today are basically this. The square root of -1 is I. Therefore, I squared is 1. Think of it in terms of the same idea of the square root of 4 is 2, or plus or minus 2. Well, let me write it differently. The square root of x squared is x. Do we agree?
Yeah.
And then if I square x squared equals x squared, right? For lack of better terms. Does that make more sense?
Yeah.
Okay. Yeah.
Is I only -1 or is it all?
Yes, it's -1. Because here's what happens. What I want you to remember is when we did the square root of, let me write that better, the square root of 12, we were able to break that down into two square roots, the product of two square roots, the square root of 4 and the square root of 3. Remember that? We would write it as root 4 times root 3, and you would get 2 root 3. Do you agree?
Yeah.
Here's what happens when you throw in the square root of -12. Instead of having 2 values, we now have 3. We write it as the square root of -1 times the square root of 4 times the square root of 3.
So,
Yeah, go ahead.
okay. So whenever there's a negative
That's
in there,
right.
and you go to simplify it, you have to put in a -1.
What you're going to do is this next step, and it's much easier than you probably anticipated.
Okay.
What's the square root of -1?
I.
The i's have it. So you would write it as 2i root 3.
Okay.
Does that make sense? What you're doing is you're factoring out a -1. The square root of -1 then is imaginary. It's I. Remember I was telling you about it's the numbers you can think of that you can't talk about? It's like your friend Bob.
Bob the Builder.
You don't have a friend named Bob? Did you have to ask your friend?
You don't have friends.
Like a little
Which allows us to do the following. What I want to do here is look at, I want to look at these two problems real quick. Very similar to what you guys did yesterday. The only thing that's changing here is that you're going to have negative value. Okay? So if I start with 2x squared plus 3 equals negative 13, the first thing we have to do to get x by itself is to move what? 3. How do you move a positive 3? You subtract it, okay. Notice that your process here isn't changing from yesterday. 2x squared is now negative 16.
Yeah.
You all right with that? Very good. Divided by 2. We have x squared equals negative 8. Once again, I have to take the square root of both sides. Now, what was the regular square root of 8? What would be the negative square root of 8?
2i.
Very good. 2i root 2. All it is,
The I is going.
do you agree that I can break, before we get it, you don't have to.
Okay.
And when you're doing the negative stuff here, it gets a little weird. Now, do you agree that I can rewrite negative 8 as the square root of negative 1 times the square root of 8?
Yes.
What's the square root of negative 1?
I.
What's the square root of 8? 2 root 2. You just put them together.
So why does I go?
Why does I go between the two? It's etiquette. You always start with the numbers first, then you can label in your imaginaries, and then you put your radical last.
I mean, if you mess up on that on a test quiz, how?
You don't want to put, as long as you have, if it's I2 root 2, as long as the i's not underneath the radical, you're fine. What I'm doing here is, like yesterday we were doing the plus minus, and we would put the negative 3 out in front of the square root of whatever. We put this constant first. You don't want to tack it afterwards because it gets messy. If this tail's too long, it might imply something different. It's just one of those etiquette things. You know how you would write answers in descending powers, descending order with the degrees? It's the same idea. It's the same basic idea. Okay? Yes, ma'am?
Since you're doing the square root of the equal sign, is it not plus minus stuff?
And that's where it gets a little fuzzy. When you're looking at the plus minus stuff here, because you're dealing with a negative root, okay? And to be honest with you, I never have, just make sure it messes you guys up. Because you use these I things, they use these more often in like electrical stuff. Yeah. Oh, they do. Yeah, throw a plus minus in, yeah. I forgot that this book does that.
So on the test, I was going to put plus minus.
Yeah, just throw plus minus in front. Now, when you're looking through these things again, sorry, first, I totally forgot that this book. I'm so used to when you do the eyes. I've been doing this stuff for how many years? So, just remember, we did the root over an equal sign. Just throw in the plus minus, you're fine to go. Let's try the other one. Same basic principle. I'll just bring it to another side. Sorry that it looks weird. So you have the quantity x minus 1 squared equals negative 7. There's nothing to move on the left-hand side. So what's the first thing you're going to do? Square root it. When you square root both sides, you're going to get x minus 1 equals plus or minus the square root of negative 7. I took the square root of an equal. How do I simplify the square root of negative 7? I root 7.
Oh. Yes.
That's it. Because remember, since this negative is here, the only thing you can simplify out with the 7 is to rewrite it as the square root of negative 1 times the square root of 7. We know that the square root of negative 1 is I. So your answer then, you get x minus 1 is plus or minus I root 7. And then lastly, what do I do? Add 1. Now, am I going to put the 1 in front of that or behind it? In front. And that's just, like I was saying earlier, it's kind of the etiquette way of writing.
Same thing, and then you add it on.
Yep. You put it in front just like we did yesterday. It's an etiquette way of doing it. That's all. Okay? I know that sometimes if you check your answers in the book, if I give you the odds, they sometimes flip-flop between putting the number in front versus the number behind. Just get in the habit of putting the constant value in front. You'll be less likely to screw something up. Okay? Not so bad, is it? It's literally one extra little step. That's it. Which lets us to do things like this, and I don't even want to do this.
What is the equation, Todd?
I don't care about the equation. You know why?
Okay, good.
Why? It's not necessary.
It's not necessary.
All right.
Yeah.
Let me ask you this. If this was 4 minus x plus 3 plus 2x, what would your answer be when you add those together?
7 plus x.
Your answer would be 7. Do you agree?
Yeah.
What do you think happens when you have an I?
Same.
The same thing. Would they ask you to combine like terms like this if you're adding stuff together? Treat the I value exactly like you would a variable. All right. Treat it the exact same way. Combine like. Think of it in terms of combining like terms. Now, notice the difference between the addition here and the subtraction here. What will I have to do differently with the subtraction to the junk in parentheses? Distribute, yeah. I got to distribute the negative to both terms. Does that make sense? You remember doing that?
Yeah.
If this was like a negative minus 2 times, you have to distribute the negative 2 to both parts. Here, what we're going to do is rewrite this as 7 minus 5i minus 1. What's minus and minus?
Plus. Did you not do plus?
I don't because it's adding. Adding doesn't matter.
But no, like,
Oh, for this part? No, because there's nothing in front of it. Because I'm subtracting the stuff behind it. What I want you to do is think of it as, what if it was 2 minus 3x minus the quantity 2x plus 4? You'd have to distribute that negative 1 to both terms. I'm doing the same thing. And the answer was? 6. The answer is just 6. Because what's 5i minus 5i?
5i. Or 0.
Okay? You get 6. We all right with that?
So that was set.
Because we're not solving this. Okay, these are just combining the terms. These are just combining the terms. Now the weird one,
how did you possibly get 6? Where did the I go?
what's negative 5i plus 5i? Nothing.
Oh.
What's 7 minus 1?
6.
Like I said, Izzy, when you're working with these and you're combining like terms, what I want you to remember is when you're combining like terms with an I, with an imaginary number, treat it exactly like you would as if it was a variable. If it was negative 5x plus 5x, it would be 0. That's it. That's it. Well, those are fish, yes.
I was just wondering, that's like, it's time.
All right?
No.
Try that one.
All right.
Try that one. What's that?
Actually, messed up.
It's, see how it's grouped into those two terms? You're going to distribute into those two terms. Correct. It's a minus. It's minus. Hold on. You're getting ahead of yourself. What I want you to do, if you're kind of leery on this, put that in front So it's negative 1. And say that you're going to distribute. So you write it like that.
But then one is like, the 6 minus 1 being
No. So what happens here, you wind up with 6. Negative 1 times negative 2 is plus 2. Negative 1 times negative or positive 9 is minus 9.
I thought that was like number 6.
Oh yeah, there's a 6 in
I
front.
thought it was question number 6.
No. And now the other side, do I have to worry about any distributive stuff? Cook, get better at golf.
I have wrong the option.
Nothing. Minus 8 plus 4i. No, because the 6 is in front of a minus sign. There's a difference here. If it was 6, the 6 would have to be next to the parentheses to distribute. But since the 6 is just here, minus the parentheses. Okay? So now you're just combining like terms. What do you get? Very good. You get negative 5i. And that's your answer.
Wait.
We're just combining like terms. We're not worried about simplifying anything else out, all right? Just combine like terms. Remember, guys, at this point here, this number here is just a positive 6 minus that junk plus other junk. So you have to distribute the negative 1 to the first junk and then combine all your like terms. Okay? This is nothing different than when this was an x a year ago, or 2 years ago, whatever it was.
Yeah, okay, that's what I did.
All right, you're doing the same thing. Yes, ma'am?
No.
Oh,
Yeah.
all right. Well, let's make this interesting.
Oh,
You're not going to die. Not right now. What is this saying? Correct. Distribute, right. This is saying 5i times the quantity negative 2 plus I. So you have to distribute to both terms. Here's what I'd like you to do for the first couple of these as you are learning how to work with an imaginary value. What I want you to do is just write out what you're doing. 5 times negative 2, so you have negative 2 times 5i plus 5i times I. Everybody okay with that?
Yes.
What's negative 2 times 5?
10.
So that's 5i squared.
Good. Now, the other one, you get 5i squared. You guys agree?
Yeah.
All right.
That's it, right?
No, it's not. What is, you're there. What does I squared equal?
Negative 1.
Negative 1. All right, so remember, the big thing for today, again, the square root of negative 1 is I, and I squared is negative 1.
So guys,
So if you
So what happens at this point here,
negative 5.
you get negative 10I minus 5. Because it's 5 times the negative 1. Okay. Now, at this point, usually what the book will do for answer-wise is they put the negative 5 in front, and they write it as negative 5 minus 10i. I'm not going to be a stickler. When you distribute, you're combining things like this. If it winds up being in that spot, you don't want to rewrite, it's okay. It's all right. Okay? Same exact idea goes for foiling. If I'm going to FOIL this out, I get the same exact process. I go first, outside, inside, last, Billy binomial. So I have 7 minus 4 times 20, negative 1 plus 2i. First term gets me negative 7. Outer terms gives me positive 14i. Inner terms gives me how much?
Negative 4i.
4i. Negative times a negative is positive. It gives me a negative 8i squared.
Yeah.
Okay.
So plus 8.
Correct. Now, at this point, what I'm going to do is I bring my negative 7 down. 14 and 4 gets 18i. This becomes negative 8 times negative 1, which is 8. Now, just like Izzy just did, she recognized right away it was negative 8i squared. She goes, oh, it's positive 8. You want to jump and write positive 8 right away? That's fine. That's fine. So now you get negative 7. And what's your final answer? 18i plus 1 or 1 plus 18i. Okay? Everybody see how very straightforward that is as far as distributive properties go? Do the other one then. Take a second, do the other one. To be honest with you, this is the stuff, people just mess up a quick sign here or there. So
Is this like as complicated as today's
I haven't done square roots yet.
Yeah. Yeah.
Oh, I'm sorry, not square roots. I haven't done fractions yet.
Fractions.
That's not
My
good.
theory is. I mean, 40 and 45. I can't add. I can't add.
Did you get 36 plus 9, you get 45?
Yeah, I can't add.
Did you notice that it was the same term, same values with opposite signs?
Yeah. Yeah.
That means it follows the pattern of a difference of squares. This really is a difference of squares, a foiled out version of it. You get 36 plus 18i minus 18i minus 9i squared. That drops out. You get 36 plus 9. Where do you get 45? Okay? Not so scary? Let me show you the worst stuff then.
Uh-oh.
Yay!
No.
Yes! Yay!
Oh, no.
Oh,
Bad.
yeah. This is so much fun.
No.
I know, it's exciting.
I think
It's very exciting.
I protest against this.
Nah, you believe it or not, you're going to see real fast that this isn't as complicated as it's going to sound. No, not yet. Let me show you this here. Here's what's going on. Just like yesterday, we didn't like radicals in our denominator. We don't like imaginary numbers in denominators. It's one of those rules that you can't have. So what we want to do is we want to multiply that denominator by something to get rid of imaginary. Now, what's different about this versus yesterday, we're going to multiply by some value of I. We're still going to multiply by a factor of 1, so the numerator is going to be the same exact value. But what I want to do here is go back to the problem we just looked at. What did you notice about these two here when you multiplied them together? When you multiplied 6 plus 3i to 6 minus 3i, what did you notice when you multiplied that and you were done? The i's were gone. Everybody see that?
Yeah.
What that is called a conjugate. Same terms, opposite signs. It's called a conjugate. So what I'm going to do here is multiply the denominator by its conjugate. What is the opposite of 1 minus 2i? 1 plus 2i. See how simple that is to what I'm going to do here?
Yeah.
And if I multiply the bottom by that, what do I have to do to the top? Same thing. Because what I want you to remember, isn't this here 1?
Yeah.
Numerator and denominator are the same. We divide it out, you're going to get 1. So what I'm doing here is I'm multiplying this funky fraction by another funky fraction to get a less funky fraction. Which means all we have to do is FOIL twice. The denominator is going to be easy. When you FOIL out your denominator, you get 1 minus 2i plus 2i minus 4I squared.
Minus, cos 5.
Positive 5.
4. It's 4, right?
No.
Oh.
The middle, oops.
Oh, yeah, well, I guess the 1.
The middles will drop, and you get 1 minus 4 times negative 1, which is 5. Okay? FOIL. First, outside, inside, last.
But isn't it like 1 minus?
1 minus a negative 5 is, or 1 minus a negative 4 is 5. Yep. Same change opposite.
Oh.
It's been a while, I know. All right? I do the same thing to the numerator. The numerator, still, it's okay to have an imaginary number within your numerator. Perfectly legitimate. You FOIL that out, you get 5 plus 10I plus 3I plus 6I squared.
It's 13I minus 1.
Very good. What happens now when you combine your like terms, you get 13I in the middle. So we know we're going to have a 13I. I have a 5 plus 6I squared is the same thing saying 6 times negative 1. So our final answer then, 5 plus negative 6 is negative 1 plus 13I all over 5.
Cool.
It's multiplying by a conjugate to get rid of the imaginary number in the denominator.
That's as far as you go.
That's, yeah, because there's something else you can do. Okay, there's something else you can do on this case, in this one. All right. The only thing that's different between this one and just a regular multiplying problem is you just have to do it twice. That's really it. All right, that's the only real major difference here. Combine your like terms and just watch what happens with your signs. Other than that, the process itself isn't all that difficult, I hope. Let's do this one. 3 minus 4I over 1 plus I, and then we'll worry about these later. Take a second, simplify this. Hopefully you multiply top and bottom by 1 minus I over 1 minus I. When you do that, you wind up with 1 minus I plus I minus I squared. In your numerator, you get 3 minus 3I minus 4I plus 4I squared, I believe? Yeah. Simplify your denominator.
2.
You get 1 minus a negative 1, which is 2. In the numerator, I have 3 minus 7I minus 4, so that's negative 1 minus 7I all over 2. Okay. I will let you know, sometimes your final answer, in this case, it didn't happen. Let's say your final answer was the following, negative 6 minus 8I all over 2. What could you do? You can simplify. Does that make sense?
Yeah.
Yeah, negative 3 minus 4I. Does that make sense, guys?
Yeah.
So don't be surprised if sometimes you get to a solution like this that it can be broken down just a little bit further. If everything is even, you can divide them all up by 2. Yes, ma'am?
Can your denominator be negative?
What's that?
Can your denominator be negative?
Yeah.
Okay.
But when you write out fractions, remember, a fraction that's negative, if it's negative 3/4, it can be negative 3 over 4, be 3 over negative 4, or it could be negative 3/4. They all mean the same thing. All right, and they all mean the same thing. Okay? Let me give you a couple of these to try, and we'll see, we'll kind of circle the wagons a little bit tomorrow, see how we're at.
So today should be 1 through 3.
No. 6 of each, right?
It's funny.
6 of each.
Let's do this. This is section 5.4.
Yeah, but these is not bad either, dude. We'll do 21. It's like four of them with equations, and then it's 5 that are just combined like terms with its addition or subtraction, and then it's 5 multiplying and 4 dividing. So it may look like it's a ton, but it's kind of on the same process through a lot of it. I gave the odds tonight so that we get an idea to check your work. Don't freak out if some of their values look a little bit different than yours do. Sometimes this book goes a little bit overboard with its simplifications. Okay? You'll probably be able to pick up on it right away. Just like I was showing you a second ago, if you had -6 minus 8i all over 2, you got that, and the book wrote it as -3 minus 4i. You know, or watch how sometimes they flip-flop them. Or another little quick thing, when you're looking at these fraction ones like this, in this answer here, how they wrote it is -1 minus 7i all over 2. What the book will do as far as its answer is it'll write it as -1/2 minus 7i over 2. You'll see those fractions broken up a lot. To me, it seems kind of like a moot point to do that. I don't really see the benefit unless, you know, this was a -4 and this, so you can simplify just a hair here or there, but just so you get the idea of what you're looking at when you get your solutions, okay? Tomorrow we'll complete the square.
Oh, I like that.
Half a b and add to the other side. Square it. Yes, ma'am. Sometimes.
Yes, I did.